This tutorial will introduce basic methods in creating surfaces and surface modeling in Rhino. Surfaces in Rhino are NURB surfaces, and they're defined as a collection of curves going in two directions. So one way to start surface modeling is by starting with a curve. So I'm just going to use the curve command to draw a simple parabola curve in my viewport. And now I can create my surface by projecting that curve and moving it in one direction. So the easiest way to start surface modeling is creating a curve that defines the curvature in one direction, and then using the extrude command to move that curve up. So I'll switch to shaded view so we can see that. So you see here we have our surface, and the first curve defined the edge here, which is the same as the edge on top. And we can think of the surface as an infinite amount of curves of this shape moving all the way across a straight line. And then in the other direction, we have the straight line that defined our extrude direction. And we can use F10 to turn on the control points of our surface, just like we did for our curves. So at first, if you create an extrusion, your control points will be based on that extrusion operation. But you can also select the surface and type explode, and this will get rid of the extrusion information and just give you the basic open surface. And now we can hit F10 and we see the control points of our surface. And the control points are the same as what we had for the curve, but now we have control points for the base curve and the top curve, and then the two control points here that define that straight line. So control points for surfaces work exactly like they do for curves, except now we're dealing with curvature and control points in two directions instead of just one. The second way we can construct surfaces is by lofting a surface through a collection of curves running in a single direction. So I'm going to go back to this curve. I'm going to use the rotate 3D command to rotate this curve up. I'm going to move it back to my origin. I'll make a few copies in my viewport, and then I'll turn on the control points for these copies, and I'll move them around to change the shape a little bit. So I'll select this top view control point here. I'll use my move up command, which is alias VV in my alias set. I can move that point up. I'll move this point over, and for the other curve as well. So now I have three curves. They all have the same number of control points and the same curvature. Now I can select them and type in loft. That's going to loft a smooth surface going through those curves. So I'll click OK. And now if we select the surface and turn on the control points, you see that again we have the control points of our input curves, and now Rhino's actually interpolated the curves running in the other direction. So we're no longer dealing with a straight extrusion, we actually have curvature running in the other direction as well. So for even more control, we can use a sweep, and a sweep is very similar to a loft, but instead of interpolating that second direction of curvature, we can actually specify that direction by creating either one or two rails in the other direction. So I'll keep my same three curves here. Now I'm going to draw another curve in the other direction. And I'll actually move this curve so it's touching that rail curve. So now I can create my sweep command. So sweep 1 creates a sweep with one rail. Click enter. So the first thing it asks you to do is select a rail. So I'll click my curve running in the other direction, and then it asks me to select any number of other cross-section curves in the other direction. I'll click them one at a time in the order that they're drawn. Hit enter and click OK. So you see that the sweep has now created this surface through both the cross-sectional curves as specified, and it follows the geometry of the rail curve as well. On the other side, however, this curve is completely interpolated and figured out from the geometry. So if we want even more control over that second rail, we can create another curve, and then I'll just adjust this control point so it's sitting on that curve as well. Now I can create a sweep 2, and I can click on the first and second rail and then through my cross sections and hit enter, and now I have a lot more control over both the 4 edges of that surface patch as well as the cross-section curves in between. So with these different operations, we're basically building up control over our surface patches. And the final way to create a surface patch has the most control and allows us to create cross-section curves in both directions, and then interpolates that surface that goes through all those curves. And that's what's called a network surface. So to create a network surface, I'm actually going to start with this first surface. I'm going to show you how to extract certain pieces of curve geometry from a surface. So I'm going to select the surface and type in the alias HH. So if you don't have these alias, you can go to the first tutorial and see how to download and import them. So HH will hide everything except for the selected geometry, so it's a good way to isolate geometry when you're working in Rhino. So this is our surface. If you click on it, you'll see these lines. Those show you the iso lines, or the curves that make up this surface in 2 directions. And because each surface is composed of a network of lines in 2 directions, we can actually extract those curves directly from that surface. And to do that, we can use the extract iso curves command, or in the alias set, it's EI. And this will allow you to extract any curve from the surface. You see these are the curves in one direction. We can hit T, or this option here, to toggle the direction that we're extracting from. So I'm going to extract first the edge curves and then a couple other curves in that surface, and then press T space to toggle to the other direction, extract the 2 boundary curves there, and maybe 2 more curves in the other direction. Hit the right mouse button or space bar to exit out. So that gives me those defining curves. And now I can select all those curves and type in network surface, and this is going to create a surface through those curves. So if everything is set up correctly and all your curves are running in just 2 directions, then Rhino should be pretty good about figuring this out. But you might run into some problems. For example, if 2 of your curves, these boundary curves, are actually joined, it's going to be harder for network surface to figure out how to construct the surface. So here it's asking actually for us to be explicit in selecting the curves in both directions. And if we go through this process, the resulting surface might not be what you expect. So before you do network surface, make sure that all your curves can be organized in just 2 sets, running in just 2 different directions. And that should create a nice surface for you. And a typical way of working with Rhino is going back and forth between extracting iso curves from an existing surface, modifying them. So for example, we can take these curves, maybe we can play with some of the control points to change the shape of that surface. And as long as your curves line up more or less, Rhino will try to fit a network surface over that. Now you see some issues we can run into is our original profile curves were very low curvature, just 3 control points, but the resulting curves have a lot of control points. So before we make a network surface, we can also rebuild the curves so they're approximately the same number of control points, the same amount of complexity. So let's select all these curves. I'll type in rebuild, and I'll give all the curves degree 3 curvature and maybe 6 control points. Hit OK. So now I'll hit F10 to visualize all control points. And now we have simpler curves, so we can work with them a little bit easier. once I've modified my input curves, they don't have to line up exactly. I can select all the curves again, type network surface again. Now it'll give you a new surface going through those curves. Click OK. And I can keep going back and forth, extracting curves in areas where I want to have more control over the surface, and then resurfacing that again. The last thing I want to show you is how to extract different curve geometry from your surface model. So we already saw extract isocurve, which will allow you to extract individual curves in two directions. Another way to extract geometry is to do dupe border. This will extract the border curves from any surface. You can also do dupe face border to extract the individual boundaries of individual surface patches in a poly surface. In this case, we just have one surface patch, so it's the same result. You can also extract the entire wireframe, including the border and any isocurves within it, with the extract wireframe command. You see here it's extracted the full wireframe. And we can change the density of this isocurves by selecting the surface, and in properties bringing up the density factor. So this will basically create a set of isocurves on our geometry. And this, in Rhino, this is just done for visualization, so it's a way to help you see the curvature better. But when we do extract wireframe, it'll actually take all those isocurves from our geometry. So this is a good way to work between surfaces and curves, and you can do some interesting visualizations by extracting that wireframe, and it has a way of showing how that curvature works.